Hi YouTube, ACDodd here. I just thought I'd take the opportunity to introduce a new series which I'm going to be doing. Don't panic, you're not going to get loads of episodes of this one. This will only be filmed as and when I get the suitable engines in. And what we're doing, and what this series is going to be called, is called ACDodd Inspex. And what this is all about is when people bring me engines, I look at them, diagnose what the problem is, and then determine what needs to be done to it. And the reason why I'm doing this is so people can understand some of the mistakes that people make, and sometimes blaming machinists when actually the machinist isn't the issue, it's actually the owner of the engine. And to start off this particular episode, I've got a lovely example of a bore wash block which was nothing to do with the machinist but everything to do with the owner. So the owner very kindly allowed me to film this so that other people could learn from his mistake. And his biggest mistake in this case with his engine block is he failed to set the fueling properly when he first started the engine and destroyed it in less than 250 miles. So here's the engine block that customers brought to me to have an inspection. Now the story about this one is it's done about 230 miles since it was first started, and unfortunately it was then producing blue smoke. So it's a good example that to start this series off. I just wanted to show you the sort of things that people come down with engines. Now the good thing about this story is the customer bought the engine and they bought it for quite a good price, and in reality there was actually nothing wrong with the machining. What was actually wrong with this one was unfortunately the owner started the engine up and unfortunately had it running far too rich. So the problem we've actually got with it is bore wash. So the reason why I wanted to start with this block is because I'll give me the opportunity to show you what bore wash looks like. So why do I want to start off with this block? Well, it's because it is demonstrating classic bore wash. So we've got the lighting set up, and we can see this the top of the bore is the honed finish, and then there's a distinct step, okay, and you can actually feel that very slightly, okay. And then we've got a bore which is polished, yeah, and then at the bottom you can see there's another step, and then what looks like to be a honed section of bore. And that's because the piston rings have stripped out the bore finish between the bottom of the bore and the top of the bore. And we can detect that by putting a dial bore gauge in. And if we put the dial bore gauge in and we start at the top of the bore, and we can see that's just about 0. And if we come down a bit, you can see past the step there's about half a thou wear. And then that, if we go right down to the bottom of the bore and we look at that step at the bottom, we can see the bottom of the bore is just about 0. Just get the parallax out of that, just say a few tenths. And then when we come up, what you'll notice is that jump, see it? And that is onto the worn part of the bore, which is caused by bore wash, and it's stripped the material out. And this is only 230 miles. So what I'm trying to say to people is bore wash is horrific and it damages your engine terribly. Now in terms of what we do about that, in this particular case, this engine needs to be rebuilt. And what I mean by that is we're going to probably bore these cylinders up to plus 40 and then restore the crosshatch finish, and away we go. And the owner in this case has installed a wideband gauge this time and a new rebuilt carburetor, and he's able to monitor the fueling when he first starts it up so that this doesn't happen again. So this is one of the piston and rods out of this engine. Now, firstly, the owner wasn't aware that the engine had come with the cheaper type of neural piston. This used to be known as the which, as you can see, doesn't have actually much holding the crown on. But when you have a cheaper engine build, this is typically what the machinist will supply you. Now, the reason why I'm showing you that is for another reason, and that is because the damage on the side of the piston. So the bores on this engine weren't particularly undersized, but what I'm trying to show you there, there we go, trying to get that nice and sharp so you can see it, is the fact is we've got some galling on there due to the fact we've been washing oil out, okay? So that piston has actually picked up the crap from the ring that was in there, and all the detritus from the bore that it's been scraping, and has actually destroyed the wall of that piston. So these piston skirts are a good 1.5 hours undersized, only in 250 miles. So as I say, when you're doing, or 230 miles I should say, when you have bore wash, it's expensive. It's an engine rebuild, it's new components, even if they were new when you first put them in. Okay, so the next bit I've got up from the same engine is the cylinder head. Now, this is a late cylinder head, in as much as it's an unleaded head, so there's no problem with that, and it's got it's been cut with an aftermarket cut for big valves. As you can see there, it's got a nice 3-angle seat. Unfortunately, someone has cut that very low, so that might be where the valve seat had some damage and they had to cut that and sink that into the head, which is kind of fair enough. But in terms of performance use, you know, with a valve sitting that low, you've got this huge ridge which is going to restrict flow. So in reality, this is not really a sensible starting place if you want a decent flowing standard or standardish cylinder head. So what we're going to do here is this head is going to go off, and I think it's going to end up with Keith Carver at some point, and look to be modified. So look out for this one, Keith. It's probably on its way to you at some point. Now, in terms of quality of machining on this head, on this whole engine, actually, the machining has not been too bad. So it's been kind of, you know, acceptable, and what I'd sort of averagely see, certainly in the UK for engine rebuilds. But the only thing I could find wrong with it is that is a standard 932 reamer, and that will not go through all the guides, okay? It should run through those guides, especially as this engine's been rebuilt, and run. So those guides are too tight. As you can see, that one barely goes through at all. So, you know, there's one that goes nearly all the way through. So when you're actually building it, there's one that goes all the way down. See, that one's the right size. So that's a carbide reamer, okay? So there's no wear on that. And you can see that doesn't go through those guides. So, you know, these guides on these A-series engines, they need to be sized once they're put in, because they go barrel shaped, you know, and in reality, you actually lose the ability to form a proper bearing geometry on the valve that goes in it, so you end up with premature wear. So in this case, this head's all going off to be done anyway, so it's not a problem. But it's just worth noting that when you have engineering work done, always check the work done by others. Hopefully you enjoyed that little episode there. Obviously, I also showed a cylinder head that was with part of the same engine. I just wanted to show you that's fairly typical of the sort of machining that we find on standard rebuild type cylinder heads. So as I say, there was no effort there to maintain airflow, but I can assure you that the individual, or the owner of that engine certainly didn't pay over the odds for it. So we're not talking about somebody that was ripped off, and, you know, in terms of the cost of the engine, what they actually got was very good for the money that they paid. Anyway, I just wanted to end that episode there with, I hope you enjoyed that. I hope you found it useful and educational. And if you want to see any more, as ever, please like, subscribe and share. Thank you very much.